right, good morning, everyone. Hope you all are doing well. I do apologize for missing class on Monday. Had some stuff come up that I had to take care of. Didn't really have the option to put that off at all. So, as a result, I did push back Lab 2 to be due today instead of being due on Monday. So I have a little bit more time with that. I did that because I missed class and office hours, so wanted to make sure that was available. Having said that, though, we're going to be jumping into the rest of the topics for data analytics. So I finished up the lecture. It's about a 10-minute video. Posted that to YouTube on Monday. But today, we're going to continue on with a little bit more notes, and then we'll jump right into things. So again, I do encourage you to take notes however you need to. So I'm just going to jump right into it. We've got the terms here inside of, I'm just in the pivot tables file. You can use whichever file you like, but just make sure that you're looking at this. So I'm going to go, stop if there's any questions. Just going to go through these. We'll see examples as we begin to do them. But in general, for a naive forecast, you're literally just predicting the previous observation. So someone throw me some numbers. 45. 17. 30. 84. All right. So let's assume that these are quarter 1, quarter 2, quarter 3, quarter 4. All right, I want to predict quarter 1 for the next year. For a naive forecast, you literally just take the previous observation, which in this context is 84. All right, now let's say that I want to predict a different value. Let's say that I want to predict quarter 4. So we know that quarter 4 has an observation. However, the naive forecast for it would be what? 30. Okay, you go to the previous observation. That's the naive forecast. Simple moving average. Simple moving average, you're taking an average. I'm going to say for this class, we're going to use a 3 for most things. So it's going to be a 3 period simple moving average. Most likely we'll be using either quarterly or monthly data. So if you're talking about a 3 period with quarterly data, that's just going to be the average of these 3 quarters. So what's the average of 17, 30, and 84? So I don't think the answer is 30. What was that? 43.6 sounds a lot better. Okay, so simple moving average. Again, you're just going to where you're predicting, getting the 3 most recent, and you're averaging them. Okay. Weighted moving average. That's where you have, in general, 3 weights. So I'll say this: the sum of weights must equal 1. All right. So you can have weight 1, weight 2, and weight 3. Okay? So you can make these whatever you'd like. They're going to be given to you in whatever problem you're doing. So someone throw me your favorite number between 0 and 1. 0.5. All right, so now we have 0.5 left. So someone throw me your favorite number between 0 and 0.5. 0.3. And what does the last weight have to be? 0.2. Exactly right. We add these up, gives us 1, right? So for weighted moving average, all you're doing is you're taking weight 1, you're multiplying it by the most recent observation. So that's going to be 0.5 times 84. And then you add weight 2, which is 0.3. It's given as 0.3, times second most recent observation, which is 30. And then finally, you take your third weight, which is 0.2. You're going to multiply that by your third most recent observation. All right, someone work that out and let me know what you get. So you said 54.5, 54.4. So the reason that's an average is because in general, when you're taking an average, okay, what you're doing is you're taking the sum of all the numbers. So sum of your x's, 1 to n, divided by n, right? And that divided by n is going to give you equal weighting for each of the x's. Okay, but what we're doing with a weighted moving average is, instead of having everything divided by 1 over 3, or multiplied by 1 over 3 rather, okay, we're assigning our own weights. It's still an average. Does that make sense to everyone? All right. So simple exponential smoothing. All right, for this one, you're going to have an alpha, and it's going to be given, and it must be between 0 and 1, including 0 and 1, so bracket 0, comma 1. And the idea here is that you take your alpha, so you have your alpha value, you're multiplying it by your previous x, so that's x sub t minus 1. Okay, so what I mean by that is x sub t would be right in the present, so that would be q1 if that's what we're trying to predict. So the t minus 1 means you go back 1 quarter, if it's quarterly data, of course. If it's monthly data, what do you do? So you go back 1 month in monthly data, right? T minus 1. Does everyone understand that? Okay. Then you add in 1 minus alpha. It's vital, that's in parentheses. And then you're multiplying that by your previous forecast value. So I'm going to call that S sub t minus 1. Actually, S sub t. It's the forecast for this current period. So let's say this is our previous forecast value, 54.4. All right. Someone throw me their favorite number between 0 and 1. 0.8. Okay, so alpha is going to be 0.8. So you take 0.8, multiply it by x sub t minus 1. What's that going to be? So if we're trying to predict quarter 1 using simple exponential smoothing, what do we do? So we're looking for the previous x. Which of these is the previous x? Okay, so we're trying to predict quarter 1 right here. So what most recently happened? 84. Okay, so you just go back 1 quarter. That's the x of t minus 1. Okay, so 0.8 times 84. Now you do 1 minus 0.8, which is, of course, is going to be 0.2. And multiplying that by the previous forecast, which we gave as 54.4. Okay, so someone work that out and let me know what you get. 78.8. Is that what everyone else gets? So in general, you know, alpha can be 0. 78 point what? 0.08. All right, so your alpha can be 0. And what happens if your alpha is 0? You're just looking at the previous forecast, right? Because what you're doing is you're taking 0 times your previous x plus 1 minus 0, which is 1 times your previous forecast. Alpha can also be 1. Okay, so you'd be looking exclusively at the previous observation. Now, if you're doing that, what type of forecast that we've talked about is that going to be the same as? So we've talked about these first 4. If you're exclusively looking at the previous value, the naive average, the naive forecast, I mean, okay? So it's the same thing if you set alpha equal to 1. Does everyone understand that? Because what you're doing is you're saying 1 times your previous x, plus 1 minus 1, which is 0. What do we know anything times 0 is? 0. Okay? 0 is my hero. All right? So seasonal naive. So seasonal naive is very similar to naive. The difference is that instead of just going to the previous observation, you're going to the previous observation within the same period. So for instance, we're predicting quarter 1. We don't go to quarter 4, we go to the previous quarter 1. Okay, so what's the answer to that going to be? 45. Okay, if it's monthly data, you go back to the previous month of the previous year, basically. So that's what you're doing there. You're going back to the same month previous year or the same quarter previous year. That's for seasonal naive, yeah. Naive, what do we do in naive? Let's go back to the previous observation, exactly. All right, so seasonality is relating to having, your different seasons. So if you're using quarterly data, you're saying, what percentage of our revenue comes from quarter 1? Okay, and the idea here is that when you have that information, it'd be very helpful to do things like demand forecast, like ensuring that you have ample coverage if you're a retail environment, those sorts of things. So we'll see examples of that, but for now, just understand seasonality relates to a period of 1 year, and it's going to be the average amount of most likely revenue, but it could be a lot of other things as well. So seasonal forecasting is whenever you take seasonality coefficients, which we'll be doing in a little bit, and you're basically forecasting your sales, maybe your demand, whatever. You're forecasting that using those seasonality concepts, which we'll do examples of. Okay, so trend. Trend is going to be a period of 1 to 3 years, not much longer than 3, not much, well, it can't be any shorter than 1, certainly. But the idea is that it's looking at growth of a business or decline of a business over that limited window. Okay, and you can, of course, forecast with that to predict future years' sales. That could be a very useful thing to do. We'll see examples of that as well. Okay, then lastly, we have cycles and cyclicity. So a cycle is going to be where we have an economic cycle. Okay, so you guys familiar with recessions? So think about it like recession to recession. That's one business cycle. Or think about it, peak to peak. That's a business cycle. Okay, so it's going to, in general, be about 10 years. I would say it can be less than that. It can also be more than that. But historically, they've averaged around 10 years. All right, and this is important depending on your industry that you're in. So if you're in an industry that has very cyclical demand, like, for example, construction, what do we know about construction demand? Is it high in periods of economic downturn? No, it's incredibly low. Okay, so that's going to contrast greatly with an industry like healthcare. Okay, is healthcare going to be drastically affected by any sort of changes in economics? Not drastically. So there's no such thing as a perfectly inelastic good or service. No such thing. Okay, it's a theoretical concept. But healthcare is relatively inelastic. The demand for construction is relatively elastic. Okay, does everyone understand that? That's what we're talking about with cyclicity. So if you are forecasting, let's say you're a construction manager, and you're trying to figure out how many day laborers should I hire, okay? Think about cyclicity. Think about where you are, not just as your company, but think about where the economy is, where you think it's going. Okay? Those are going to be vital things to understand. So any questions? Anything I need to repeat? So we're going to see some examples of it, but in general, seasonality is just looking at how much of something is going to be explained by whatever season of interest we have, be it quarter, be it week, be it monthly, is looking at how much of that can be explained by that. Any other questions? All right, you guys ready to jump into some examples? I certainly am. Let's go ahead and go over to monthly data. Let's go to the monthly data worksheet here. And what this is real data, okay? So this is plotted out. We have year 1 through 3. We have month listed as the actual month that something is. And we have count. And that's how many of a particular type of transaction there were. All right? So let's just go ahead and start kind of basic. We want to do sum by year. All right, so there's a couple different ways we could do this. All right, someone tell me one of the ways we could calculate the sum by year. It's one way I could add up the counts by year. It's one way. Okay, I can use sum, that's right. So I'm just going to grab everything for year 1. All right, someone tell me another way I could do this. Okay, exactly right, sum if. Okay, so I just use sum if. I can put in the range. Now that's going to be my year column, because as we know, we always start off with the range as being what we're wanting to look at for the criteria. The criteria is just going to be 2, because we're looking for year 2. And then finally, the sum range is going to be the C column. All right, so I can just close that off, hit enter. And now, if I were so inclined, I could copy this down. And all I have to do is just change 2 to 3. All right. So let's go ahead and remove this average annual trend for now. And let's go ahead and calculate it. So, as I said, trend is looking at periods of growth or decline over a 1 to 3 year window. So since we have 3 years of data, why not use all 3? Okay, so what we're going to do here is going to open up an equation, just hit the equal sign, open up 2 parentheses. We're going to divide our year 3 into our year 1. And we're going to subtract off 1. And the reason we're doing that is we want to get the raw percentage without having it be over 100%. All right, so that's why we're taking off the 1 right there. Close off the second parentheses. And because we're not just going from year 1 to year 2, we're going from year 1 to year 3, we're going to divide this by 2. Okay, so that's going to allow us to get this in an annual format. So on average, we're growing 28% a year. All right, is everyone with me so far? Okay, so now if I want to calculate a trend forecast, all I have to do is just take this value right here. Okay, I'm just going to add 1 to it, and then I'm going to multiply it by my previous year's forecast. So in other words, I can just take this previous year's forecast. We know we're growing 28% a year. So if I want to calculate how much we actually expect to have in total for the next year, we have to add 1 to 28%. Because otherwise what we're doing is we're multiplying this number by 0.28. Okay, we want to multiply by 1.28. Does that make sense? So that's why we're adding 1 there. So just open up the parentheses, do 1 plus G2. Close parentheses. And then we predict 41,018 for the year. All right, did I lose anyone on any of this? Yeah. Are you on monthly data and not monthly data 2? It should. Does everyone else have it look pretty similar? Yeah. Okay, so did you do this? Yeah, so it's very important to match up the parentheses. Because, again, what we're trying to do, before we do anything else, we're trying to divide year 3 into year 1. Then we're subtracting off 1 because we want to get the raw, instead of having it be 128%. we want it to be just 28%. So that's why we're subtracting off the 1. And we're dividing by 2 because we're not just going 1 year, we're going 2 years. So that's why we're doing that. But definitely make sure you match the parentheses exactly. All right, any other questions? And everyone understands how I got the trend forecast for year 4, right? So just to make sure everyone's on the same page, take your previous year. You know you're growing 28% a year. So you're going to take your previous year, multiply it by 1 plus your average annual trend. All right. So now let's calculate the average by month. All right. So how can I do this? Could I manually compute the average by each month? So I could take the average of this, and January year 3. Could I do that for all of them? What's a better way? Average if, exactly right. Okay, so we're going to use a good friend average if. Now for the range, we're going to use the month column, obviously, because that's where our criteria is going to be found. Now here's a cool little trick. See how the January is going to match up exactly with January? So we can use what type of reference to save us a lot of time and allow us to copy that down? Okay, we can use a relative reference to cell J2, right? And that's our whole criteria. All right, now finally for the average range, we're just going to use the C column for that, because ultimately we're wanting to average those counts. All right, so we're just going to copy this down. Whoops, copy that down. Going to remove some of this. Okay, so there's 2 parts to grand total I want to talk about. So in general, a grand total is going to be the sum of everything you have. So we're going to add up the entire C column. All right, and that's part of the grand total. The other part is we want to add up these averages. Okay, so we're going to do it in both ways. So all I have to do is take the sum of the C column. I'm going to select the range so I don't, just the whole C column is fine. Okay, that gives me 80,848. What's the other thing I want to take the sum of? There's one other thing I said I wanted to take the sum of. What was it? That's exactly right. Okay. So we're going to take the sum of these averages by month. And what would this number be the same as? Would it not be the same as me coming over here and taking the average of years 1 through 3? Yeah, it's going to be the exact same. Okay. So that's going to be useful for us. Because now what we want to do is we want to calculate the seasonal constant. Okay, and for the seasonal constant, what we're doing is we're taking the average by month and we're dividing it into this value right here. Okay, and ultimately that's going to give us a proportion that each month is responsible for in our sales. Does that make sense? So what should those values add to? What should our seasonal constants add to? So if we're taking all of these numbers, dividing it by this number, what should that add to? So you guys understand that this number right here is a sum of all these, right? Does that help? So someone just guess. What will these seasonal constants add to? So let's just go ahead and do them and see what they add to, okay? So again, what we're doing is we're seeing the average by month, how many we get in average in January, how many we get on average in February, and so on. And then we're just dividing that into the basically the sum of those averages. Okay. Now, what type of reference do we want to make the denominator? An absolute reference, because we want to copy that down, right? Does everyone understand that? So just hit F4. It's an absolute reference. Okay. So now that you can see these, what do you think that these will add to? Okay, 1. That's exactly right. So if we just come over here, do sum of these values, we get 1. And that should be pretty apparent because all we're doing, taking each of these values, we're adding them up to get this, and then we're taking each of these values, we're dividing them into this. Okay. So in other words, we're saying that 10% of our demand is in January. We're saying that 12% of our demand is in August. Okay. Does everyone understand that? So that's the seasonal constant. You got a question? So what you're doing is you're just taking your average by month and you're dividing it by the sum of these. So if you got 0.94, you probably divided it into this or something else. All right, does that make sense? Yeah, I could take a look at it with you after class if you're still having issues. But in general, we now want to predict our future demand for year 4 by month. So we've already computed that we expect to have a total of 41,018 sales in this particular year. And we've also determined that each month what we expect the demand to be in terms of the percentage. So going back to this, someone throw me your favorite month. Okay, January has 10.4% of the sales. Someone throw me your favorite month again, different month. Okay, so August has 12.7%, almost 12.8. All right, does everyone understand how that works? So how do you think we may be able to figure out what we're expecting to have in the month of January year 4? Okay, so we have year 4's total sales, and we have the percentage that we expect it to comprise for each month. So all we have to do then, just take year 4, make that an absolute reference. We're just going to multiply that by our seasonal constant. All right. We just copy this down. Okay, and now when we add this up, what should this add to? Should add to this value right here, right? Because all we did is we multiplied that by 1. So if we multiply something by 1, what should it be? It should be the value. So let's just take a quick little sum and make sure we didn't make a mistake. Okay, and of course we did not make a mistake. All right. So all we're doing is multiplying by 1. It's totally okay to multiply by 1. All right, that's not an issue at all. Is everyone with me? Okay. Well, let's go ahead and do some forecasting. So the Naïve forecast for January. All right, how do we calculate that? So we want to get January year 4. What are we going to do? The previous value, which is going to be December year 3, right? That's exactly right. Because in the Naïve forecast, we just go to the previous observation. All right, seasonal Naïve for January. What do we do? So we're going to go to January year 3 for January year 4, right? That's exactly right. Okay, if I ask for a 3-period simple moving average to calculate the simple moving average for January year 4, what do I do? So we're going to start with average. That's right. What are we averaging? The most recent 3, in this case, months. So we just take the average of that. Okay. Now for weighted moving average, someone throw me your favorite weights. Any weights. 0.5. Weight 2 going to be? Said 0.4 and 0.1. Do those numbers add to 1? So we can use them, right? Alright. So for this, make sure I'm clicked inside the cell. Start off with equals. Come down here and put in your first weight, which is 0.5. Multiply that by what? Your most recent observation, right? Okay, now here's a trick. We know order of operations specifies multiplication before addition, so we don't have to use parentheses here. You can if you want, but you don't have to. Okay, so our second weight is 0.4. Multiply that by the second most recent occurring. And finally, our third weight is going to be 0.1. Just multiply those together and add them up. And that gives us a weighted moving average of 2,096.8. All right, we could change those weights around if we were so inclined. The weights are going to be given to you, though. You don't have to calculate them. And then lastly, someone throw me an alpha. 0.05, you said? Okay, we can do that. It's between 0 and 1. All right. So again, just to remind everyone, start off with your alpha, so 0.05 in this case. And we're going to multiply it by the most recent observation. Okay, and now all we have to do is just add 1 minus 0.05. Make sure that's in parentheses. Multiply that by your most recent forecast. Most recent forecast, just use the weighted moving average value we just computed. Multiply by that guy. All right, does everyone understand this? Okay. So that's what you're doing with monthly data. Are there any questions? Anything you guys need to see again? Anything you need? Yeah. So the simple moving average, we just use a 3-period simple moving average. So we just took an average of the 3 most recently occurring values. Any other questions? Okay, so the weights, we just took the weights that were given and just multiply them by weight 1 goes to the most recent occurring value, weight 2 second most recent, weight 3 third most recent. Any other questions? All right. Let's go ahead and go over to quarterly data. So these numbers are a little bit larger. All right, so someone remind me how I can calculate the sum by year. How do I do that? What function? Sum if. Okay, so our range is going to be the A column. We're going to use a relative reference to the F column for the criteria. And finally, the sum range is going to be the C column. All right, does everyone understand that? Okay, and now we can copy this down. Okay, so if we wanted to, we could certainly compute the average annual trend. So we're just going to take 2014, divide that into 2017. Okay, we're going to subtract off 1. Whoops, I missed the parentheses there. And instead of dividing by 2, we're going to divide by 3. Why divide by 3? Exactly right. Okay, so that's what we're doing there. But we're not going to do trend forecasting. So yeah, we're not going to do trend forecasting on it, but basically what you're doing is, see how this number is, let me make these a little bit bigger so we can see them. I like stuff formatted as numbers personally. So the idea here is you're seeing the growth or decline, okay? But I just want to make sure we're all on the same page though with the forecasting. I think that's what's important. That's what you're more likely to see on exams and stuff. So seasonal, let's do the Naïve forecast first. So you'll notice this data is laid out a little bit differently. Okay, so we have the year in this case, descending order as opposed to ascending before. So what does that mean we're going to use for quarter 1 of 2018? What is that going to be? So we're going to go to quarter 4 of 2017. So you have to pay close attention to that whenever you're doing the data. So that's going to give us C2. All right, so for seasonal Naïve, someone tell me what I do for this. So we're going to go to quarter 1 of the most recent year, which is 2017, right? All right, simple moving average. What do I do? Average the 3 most recent. Okay, that's exactly right. Let's use some different weights this time. Someone throw me your 3 most favorite weights. Anything. 0.2, 0.6, and 0.2, right? All right, so all we have to do, start off with equals. First weight is 0.2. We multiply that by what? 2017 quarter 4. Now we add in the second weight, which is 0.6 times second most recent occurring value. And finally, we add in the third weight times third most recent occurring value. Okay, that's going to give us what? It's a weighted moving average, right? Okay, because we applied the weights, and it's a weighted average. It's not an arithmetic average. All right, so that gives us a very large value. Okay, these are large figures. So that's the weighted moving average. Now finally, someone throw me your favorite alpha. So 0.7. Okay, so let's just come right here. 0.7 times most recent value plus 1 minus 0.7 times the most recent forecast. We're just going to use weighted moving average again. Okay. Does that make sense? So we've got about 15 minutes left of class. What I'm going to do is, if you don't want to see another example, you're free to go. I'm not going to hold you. But if you do want to see another example, we'll go ahead and begin. So I'll give you until 9:47 to make up your mind about that, and then we'll jump back into another example. So if you feel pretty confident, feel free to head out. If you'd like a little bit more practice, feel free to stick around. Yeah. So the Naïve forecast, you're just taking the most recent value. So it's just going to be, in this case, C2. Yeah. And that's because in this context, this is the most recent. So the sum by year, you're just using SUMIF. All right, if you'll go ahead and go over to monthly data 2. All right, so if we scroll down, we don't have a product cost. But we can assume that product cost is a fixed cost. So someone throw me your favorite number. Okay, 7. So we're going to say each month has fixed cost of $7. Okay, pretty low, but certainly possible. All right, so what we can do to calculate the product cost, just take your product cost, divide it by how many you sold. Okay? This is where it's important to understand that if you have more of something and you sell more of it, obviously, you'll have a what type of product cost per item. So if you only have fixed costs, and if you sell more of something, specifically think about the context of digital distribution. Okay, let's say I develop an app. I put it up on the App Store. My costs are $100,000 for the app. Okay. If 100 people download it, am I going to have more or less cost per than if I have 100,000 people download it? Okay. So as we increase our sales, looking at fixed costs exclusively, of course, we expect our product cost to decrease. All right. So sum by year. What do? Sum if. And again, we don't have typed out, so we're just going to use the A column for the range. We're going to manually type in at 1 for the criteria. And finally, for sum range, we're just going to use the C column, just like we have before. All right, does everyone understand this? And now we can just copy this down. And when we copy it down, we're going to have to make sure we go in, change it to 2, and change it to 3 for the criteria, respectively. Right, so that's what we're doing there. We'll come back to average annual trend if we have time. I don't want to hold class too late. Like I said, the bigger focus of this class is definitely going to be the Naïve forecasts, all those sorts of forecasting. So, say I wanted to forecast for January of year 4. How do I do it? Okay, so we go right here, right? And that's all we have to do for Naïve forecast. Okay, let's say we don't want January year 4. Okay, let's say we wanted to get March of year 2. Okay. So how do we get this? Okay, what am I going to do? February year 2 is exactly right. One more for fun. How about June year 3? What do I do? May year 3 is exactly right. Okay. Does this make sense? Is anyone confused? Like I say, I'm always happy to address any questions you may have. So for seasonal naive, do the same type of thing, but for January of year 4, we go to January of what year? Year 3. Exactly right. For March of year 2, we go to March of what? Year 1. And finally, for June of year 3, we go to, so June of year 3, or 2. All right? And that's what we're doing there. So you're just going back a year, same period, though. It's back a year. So the same thing with a simple exponential, or a simple moving average, rather. We're going to calculate it for January year 4, March year 2, and June year 3. So for this, just use the average. Come down here to our 3 most recent periods. Take the average. Same thing with March year 2. So we're going to use the 3 most recent things to March year 2. So that is going to be February, January, and December. So it's going to use equals average. February, January, December. And that, of course, gives us March year 2. So finally, for June year 3, start off with the average again. Okay. All we're doing is we're going to June year 3. We're going right before that. We're just taking those averages. All right. Questions? Is everyone on the same page so far? All right. What weights do we want to use this time? Okay. So, we start off, we go to January of year 4. That's what we're trying to predict. So we go the 3 most recent to that. And our weight is 0.1 times first most recent value plus weight 2, which is 0.6 times second most recent value plus 0.3 times your third most recent value. Okay, does everyone understand that? So you're going to be given the weights, but let's say you're working for a company. You would determine the weights based on what you think is the most likely predictor. So for instance, if you're using quarterly data, you may not put the most recent weight, you may not put weight 1 the highest, you may put weight 4 the highest, and that will make a lot more sense. Okay? There's a lot of logic and stuff behind this, but for now, you're just going to be given the weights. That's a good question, though. So again, for March of year 2, we go to March of year 2, start off with our first weight times most recent value for that, which is going to be February year 2. Add in our second weight times the second most recent. And then finally, we add in our third weight times third most recent. Okay. Next, we want to do June of year 3. So just like before, come down here to June of year 3. And first weight times first most recent value, which is going to be May year 3, plus second weight times April of year 3, plus third weight times March of year 3. And that gives us the weighted moving averages. All right. Does that make sense? Anyone confused? So finally, we have simple exponential smoothing. Okay. So for simple exponential smoothing, someone throw me your favorite alpha. Any value you want between 0 and 1. 0.5. Okay. So all we do, just take 0.5, and we're going to multiply that. Multiply that, of course, by the most recent value down here, plus 1 minus 0.5 times, in this case, we're going to use the previous forecast. So again, we're just going to use the weighted moving average for that previous forecast. On an exam, the previous forecast value would be given. So we just do that. That gives us simple exponential smoothing with that alpha. Do the same thing here. Take 0.5 for March of year 2. We're going to go over to February of year 2, obviously. Whoops. So C15. Times 1 minus, whoops, got an extra times in there. Should be plus 1 minus 0.5 times our previous forecast, which we're going to use is this 164. Okay, and then lastly, we have June of year 3. So we're going to take 0.5, multiply that by May of year 3. 77 plus 1 minus 0.5 times the previous forecast. And that's really all there is to it. So I'll take any questions. Go ahead and end class. Hope you all have a great day. I will see you all Friday. Actually, Friday's optional. If you want to come and work on the lab, you may. If you would not like to work on the lab, you don't have to. So have a good day, everyone.